So in terms of what we went over last video, in terms of visualizing the data, we already ran library stack cal poly package, and that's nice and cool. However, let's go ahead and create a new window. And so our new tab, or new file. The easiest way to do that is to click here where you see that plus and that down arrow, and just click R script, or you can press Control Shift N. And what we can do is we don't have to run library stack cal poly package again. But what we can do is chi-square. So already has this function called chi-square test, right? And so in order for us to actually run this, we had to utilize that table function that I specified before, okay? And then get access to the data. So start typing King County, and then $, and then race, okay? And so when I run this, what this is going to do is it's going to run a chi-square goodness of fit test. So whenever you input just one categorical variable, it's going to do a categorical it's going to do a chi-square goodness of fit test. So when I run it, okay, it gives me my test statistic, and it also gives me my p-value as well as degrees of freedom. Okay. All right. And so let's continue on. Let's talk about the chi-square test of independence. Okay, so the chi-square test of independence, you start typing it, it shows up. And so this time we don't have to use the table function. And so what you'll do is you'll do King County, okay? Remember, since it's a test of independence, as you'll see in class, you'll do you have two categorical variables. So you can do King County data of gender, and you have King County $, of race. Again, they both have to be categorical variables. Okay, one can be categorical binary, and the order doesn't matter. I know that's going to be a question that you all ask as well. And so when I run this, I also get a chi-square test of I'm implementing the chi-square test of independence. I get my test statistic, I get my degrees of freedom, and also get my p-value. Okay, that's fantastic. All right, so one other quick side note. We can create a contingency table by running table of these two variables together, okay? So when I run this, I'm going to get a contingency table. So here is gender along this axis, and then here is race along this axis, okay? And so then it gives you the frequencies for each and every row and column, okay? So that's quite interesting. So the reason why this is important is because if I wanted to do a two independent sample proportion Z test, that's going to require me to utilize that table function within another function. What does that look like? So the function that we're really interested in is called prop.test. Okay. And so what I then need to do is use the table function. And I'm going to mention this in class and also right here, is that it's really important that you can only use this test when you have two categorical binary variables. Okay. If you have two categorical binary variables, that's the only time you can use this. If one of them is categorical and the other one's categorical binary, you have to use the chi-square test of independence. However, if it's categorical binary and another categorical binary variable, and you're trying to do a hypothesis test or a confidence interval, this is the functionality, or this is the function that you would use. So you would run table, right? Then you do King County, and you do gender, comma, King County, and what we're seeing is we're going to look at another categorical binary variable, and that's going to be a drinker. Either they drink or they don't drink, or they have a male or a female. Okay. And the only new thing that I'm not going to go into too much explanation is that you're going to say correct is equal to false. Okay. You can just make that go there. And when I run this, not only does it give me a test statistic, it gives me a p-value, it gives me the degrees of freedom, it also gives me the confidence interval. Okay, it also gives me the confidence interval. And again, if I wanted to summarize that information, you can just copy and paste this here. You get that summary. Okay, so that is it, and that's great.